Okay, today's who are they? Sadia Islam. Okay, good. Okay, welcome to my class. This chapter 19, chapter title Energetics. Today topic is exothermic reaction and endothermic reactions. Topic I didn't write here. Um, Look, this is a chemical reaction. Here's what happened. Look, it is a quicklime here, calcium oxide quicklime. If we add water, quicklime, we see bubbles, energy surrounding area, reaction medium become hot, and this is because energy released to the surrounding, so it become surrounding become hot in some reactions. Some reaction we see energy surrounding area becomes cool during the reaction. We see this chemical reaction in combustion reaction in our house. We know natural gas is methane. Actually, here is a 90 in Bangladesh. 98, 99% gas is methane in natural gas. Natural gas methane, burning natural gas in presence of oxygen. This is the combustion reaction. This is occur always in our house. In our house, this reaction, heat is released to the surrounding. Heat is released to the surrounding. In some reaction, heat is gained from the surrounding. Heat is gained from surrounding. Some reaction, like if you have you add glucose in water. Glucose in water, if you add glucose, you see this surrounding become cool become. In this reaction, energy is gained from the surrounding. As a result, reaction medium become cool. In some reaction medium become hot if released energy. If gained energy, reaction medium become cool. If released energy, reaction medium become hot. Here released energy to the surrounding, so it become hot. So depending on the heat, energy, heat released to the surrounding or gained to the from surrounding, reaction is two type. One is exothermic reaction, another is endothermic reaction. Today's topic is energetics. We learn know the chemical reaction in which heat energy is given out as described as exothermic reaction, and those in which heat energy is taken are described as endothermic reaction. Then we learn some example of exothermic reaction and endothermic reaction. Then we learn draw and explain energy level diagram to represent exothermic and endothermic reaction. These things we'll learn next part. This chapter is two part. I divided. I am taking to the first part. Second part I will take this uses of Born energy. Second part I will discuss using Born energy to calculate enthalpy change during chemical reaction. Look, in this reaction, endothermic reaction, look here, energy is gained from the surrounding. Heat is gained from the surrounding. So it is endothermic reaction. In endothermic reaction is cooler than surroundings. Like here is the exothermic reaction. Exothermic reaction, heat energy is released to the surrounding. So surrounding becomes the exothermic reaction is hotter than surrounding. What is exothermic reaction? exothermic reaction is a reaction or process. Rafi Hussain, what are you doing? Exothermic reaction are reaction or process that release energy, usually in the form of heat and light. In exothermic reaction, total energy of the product is less than total energy of the reactant. So in a exothermic reaction is a process or reaction in which energy is released to the surrounding. An exothermic reaction is a reaction for which the overall standard enthalpy change delta H is negative. Delta H is negative. Why in exothermic reaction energy is released to the surrounding? Do you know? During the look, this is Rafi, I should remove this. Okay, I removed him, Rafi Hussain. So here is a bond. I have said in exothermic reaction energy is released to the surrounding. Here this is exothermic reaction. This is combustion reaction. It occurred at our house. In combustion reaction, when combustion reaction occur, carbon dioxide and water is produced, and some energy is released to the surrounding. Okay, these are reactants. These are reactants. These are product. These are reactant. This is reactants. Substance which participate in the reaction are reactants. These are reactants. So reactants are methane and oxygen are reactants, and carbon dioxide and water is products. Okay. This reactant contain bond carbon hydrogen, this here bond carbon hydrogen bond, and oxygen oxygen double bond. Here this is bond. Look, look, this is methane contain how many bond? Carbon hydrogen bond. Methane contain carbon hydrogen bond. Here 4 methane contain carbon hydrogen bond. And here oxygen contain oxygen oxygen double bond. Okay. During the chemical reaction, reactants bonds are breaking. Reactants bond are breaks. Reactants bond are breaks, and products bond are formed. Here products is carbon dioxide like here is a bond, carbon oxygen bond. This way is a bond. Here is a carbon oxygen double bond in carbon dioxide, and water bond is water bond here this way, 2 bond this way, carbon hydrogen bond. Okay, this bond, 2 bond, oxygen hydrogen bond, oxygen 2 bond. So here during the chemical reaction, reactants bond are formed, products bond are reactant bonds are breaks. This bond are break, this bond break, eh? All bonds contain energy bonds, and products bond are formed. This product bond are formed. Products bond are formed during the reaction. Reactant bonds are breaks, reaction bonds breaks, and product bonds are formed during the reaction. All bonds contain energy. All bonds contain energy. All bonds contain energy. So here during the reaction, bond breaking energy in a exothermic reaction, bond breaking energy is more. Bond breaking energy is more than bond formation energy. In an exothermic reaction, bond breaking energy is this bond here, carbon hydrogen bond, 4 carbon hydrogen bond, 1 oxygen double bond. Bond breaking energies is more than product formation energy. Like for example, like it is 400 kilojoule energy for bond breaking, and for bond formation energy is 300 kilojoule. Always in a exothermic reaction, bond breaking energy is more than bond formation energy. When product reactant to product is formed, this excess energy, how much here excess energy? 400 kilojoule, 300 kilojoule. Here is a 100 energy is excess. This excess energy is released to the surrounding. So for these regions, in an exothermic reaction, energy is released to the surrounding. This 400 kilojoule, this 300 kilojoule, this is not actually. I have given an example for this reaction. Here, suppose bond breaking energy is more than bond formation energy. In a exothermic, why in exothermic reaction energy is released to the surrounding? Because in exothermic reaction, bond breaking energy is more in reactant than bond formation energy in products. For as a result, excess energy is released to the surrounding. For this region, energy is released to the surrounding in exothermic reaction. Look, this is a exothermic reaction. Energy is released to the surrounding. Heat energy is released to the surrounding, and temperature goes up. Look, this is a thermometer. Temperature goes up as temperature increased. So temperature rise, goes up. Here in a exothermic reaction, reactant energy is more. I said reactant energy is more in exothermic reaction than product energy. Delta H is enthalpy change. Delta H is enthalpy change. Heat is evolved. That means released. Heat is released, evolved. Here reactant energy is more than product energy. Here is the energy is increasing here. Progress of the reaction is occur this way. So exothermic reaction, this is the profile diagram or energy diagram of exothermic reaction. Example of exothermic reaction: any combustion reaction is exothermic reaction. All combustion reaction with oxygen is combustion reaction, like methane, CH4 plus oxygen, this is the combustion reaction. C2H6 ethane plus oxygen, combustion reaction. Carbon plus oxygen, combustion reaction. Any reaction with oxygen is the combustion reaction. All combustion reaction is exothermic reaction. In this reaction, energy is released to the surrounding. Surrounding area becomes hot. All neutralization reaction is uh, uh, exothermic reaction. Acid and base react from salt and water. This reaction is neutralization reaction. All acid base reaction, acid and when acid react with base from salt and water, this reaction is neutralization reaction. Rusting of iron is the exothermic reaction. Thermite reaction, reaction between water and calcium chloride. This exothermic reaction between sodium sulfite and bleach, dilute sodium hydrochloride. Reaction between potassium permanganate and glycerol. These all are exothermic reaction. Combustion reaction, neutralization reaction. Do you know combustion reaction? This is a one combustion reaction with oxygen from carbon dioxide and water. This reaction is combustion reaction. And neutralization reaction is reactant is acid and base, like reactant is acid and base, like sodium hydroxide base, sodium hydroxide from salt and water, salt sodium chloride, and water. I gave this example. All acid base reaction, neutralization reaction is exothermic reaction. Here heat is released to the surrounding. This is one example. Hydrochloric acid and sodium hydroxide form sodium chloride and water. This is exothermic reaction. All neutralization reaction is acid base reaction, exothermic reaction. Draw energy level for the exothermic reaction. Draw energy level diagram. This look something missing. Draw energy level diagram. What? Draw energy level what happened? Okay. Samir now joining. Okay, draw energy level diagram for exothermic reaction. How to draw this energy level diagram for exothermic reaction? At first you give this x-axis and y-axis energy level diagram for exothermic reaction. This is drawing energy level diagram of exothermic reaction. Here is a this is y-axis and x-axis. In x-axis you write progress of reaction, path of reaction, this route of reaction, progress banana is spelling progress of reaction. Here energy in y-axis is energy. We know this reactant. At first we write here reactant at the beginning. We know this exothermic reaction reactant energy is more than product energy. So we write reactant energy here and product energy below. Reactant energy is this is the reactant and this is the product. This is the reactant energy. Reactant energy, this is the reactant energy is more than product energy. Reactant energy is more than product energy. So at the top I write reactant energy for exothermic reaction. Okay, this is exothermic reaction. So when reaction occurs, some energy, minimum energy is required for to collide. This is called, so energy increase, this energy down. This is the some minimum energy is required, some energy. This is called activation energy. Look, this energy here, reactant to this energy. This is activation energy. Some energy is required to collide reactants. Some energy is required to collide reactant. This is activation energy. This energy. This is activation energy. So this is the energy level diagram for exothermic reaction. Energy level diagram for exothermic reaction. 10 minutes is remaining. After 10, okay, when finished, I'll take another meeting. Okay. This is the energy level diagram for the exothermic reaction. This can be written this way. This way written in your book. Here energy is released to the surrounding. You write arrow from reactant to product. Arrow is sign. You write from reactant to product. Here is delta H written. How delta H I will write here? Oh, I can write this way by writing delta H. Delta H. Delta H means energy is heat is released. Heat is released or evolved. Heat is released. It is released or evolved. Released. Heat is released. Okay. This is the diagram figure energy level diagram of exothermic reaction. Figure energy level diagram for exothermic reaction. Exothermic reaction. Okay, this is energy level diagram for the exothermic reaction. Okay, now I am going to here is the reactant energy is top more. Reactant energy is more than product energy. Product energy is less. Reactant energy is more. For this reason, in a exothermic reaction, energy is released to the surrounding. When reactant to product is formed, this excess energy is released to the surrounding. For these regions, exothermic reaction release energy to the surrounding. Now next topics I am going to Samir, what is it? Now endothermic reaction. Some missing here. Okay, endothermic reaction or reaction is process that energy gains from surrounding. Energy gains from surrounding. So surrounding is become cooled as well in the form of heat and light. In an endothermic reaction, energy is absorbed from the surrounding. In endothermic reaction, for which overall standard enthalpy changes, standard enthalpy change delta H is the standard enthalpy change, energy change. Energy change delta H is positive. Delta H is positive endothermic reaction. Here energy is gained from the surrounding, absorbed from the surrounding. As a result, it become cool surrounding. Look, this is an exothermic reaction, endothermic reaction. Here look, delta H is positive. Delta H is positive for this region. Here energy is gained from the surrounding. When calcium carbonate is heated, it must give heat. If we supply heat, this calcium carbonate break down from calcium oxide and carbon dioxide. This is a decomposition reaction. Decomposition reaction. Here energy gained and from absorbed, and look, this reaction heat is gained from the surrounding. Heat if gained from the surrounding, what will be? Temperature is fall. Surrounding temperature goes down in a thermometer because heat gain, so temperature goes down. This is the energy level diagram for the endothermic reaction. Product energy is more. Product energy is more. Reactant energy is less. Reactant energy is less. This enthalpy change, heat is absorbed. Enthalpy change, heat is absorbed. So you will understand. Here at first you will write at the bottom below reactant, above is product. Then you draw a reactant to product. This way arrow is give sign. This is the reverse. But you at first you should write reactants. Here you write products. Then reactant to products. Reactant energy is more than product in endothermic reaction. Example of sorry, this is exothermic reaction, not this is endothermic reaction. If face problem again. This is endothermic reaction. Some example of endothermic reaction: melting ice. Melting ice is endothermic reaction. Melting of solid salt. Yeah, what's my cursor? Solid salt. Melting solid salt is endothermic reaction. Evaporating liquid water. And decomposition reaction. This endothermic reaction. Look, this is endothermic reaction. Photosynthesis. We feel cool if photosynthesis occur because this is a endothermic reaction. Energy gained from surrounding, the surrounding become cool. Tea plantation, so we should need more tea plantation. Here this is the rainy season, appropriate time for tea plantation. This is photosynthesis. This is a endothermic reaction. Instant cold heat, cold pack is used. Cold pack and cooking egg, this is also endothermic reaction. Photosynthesis, instant cold pack, cold, here is not seeing here. Comparison between exothermic reaction and endothermic reaction. Exothermic reaction, system loses energy. Endothermic reaction, system gains energy. Surrounding gain energy. Surrounding loses energy. Surrounding become cool. Surrounding become hot as gain energy. System lose energy. Surrounding feel warmer. Exothermic reaction, surrounding feel cooler. Here delta H is negative. Exothermic reaction, delta H is negative. Delta H is positive for endothermic reaction. Okay, look, this is a question problem. Draw an energy level diagram for this process. This is two reaction. This is the one reaction. This is the second reaction. Sulfur and oxygen. From sulfur dioxide, delta H is negative, 297 kilojoule per mole, and copper sulfate and copper when heated, decomposition reaction occur. Copper oxide and sulfur trioxide is formed. Delta H is positive. Okay, here is question: draw an energy level diagram for this process and label the axis. X axis, Y axis you label. and show clearly reactants and products and enthalpy change of the reaction on your diagram. Okay, look, what type of reaction? First one, hello student, say. First one is say exothermic or endothermic reaction. Hello student, 1 minute remaining. Hello students, 1 minute remaining. You solve this problem of question first one. Hello students, take an screenshot and first question solve. First question solve. Take a screenshot. Less than 1 minute remaining. First one solve. Less than 1 minute remaining. So I am. Have you taken a screenshot? Take a screenshot to this. Draw energy level diagram for this process. Label the axes and show the clearly. This is problem solve. Draw energy level. Draw an energy level diagram for this process and show also axes. Two axes. So axes show the clearly the reactant and products enthalpy energy level reaction and enthalpy change of reaction on your diagram. Okay, so at first we'll draw the energy level diagram. The first one, sulfur plus oxygen form sulfur dioxide. This is delta H is negative. Delta H is negative, so the exothermic reaction. We know delta H negative is exothermic reaction and positive is endothermic reaction. This is exothermic reaction. So here which one is more? Reactant energy is more or product energy is more here? For this region, this is exothermic reaction, so reactant energy will be more. This is reactant energy will be more. This is reactant, sorry, this is reactant energy is more than product energy. Product energy is below. Reactant energy is more. So here is a reactant. Reactants are here is a product. Products. It is the progress of reaction. Progress reaction, progress of reaction. Oh, sorry, this is reaction, progress of reaction. Here is the energy. Two axes you should axis. What is right? Y axis energy. Energy. Here is energy is increasing. X axis progress of reaction. Okay, reactants. Okay, here is the reactant is sulfur solid and oxygen gas. These are reactant. Reactant is sulfur solid and oxygen gas. Okay. Product is sulfur dioxide. Product is sulfur dioxide. So product is sulfur dioxide. Product is sulfur dioxide. this gas. Okay, you will give arrow from reactant to products. Reactants is top, so reactant to product, this will give arrow. Here delta H is what? Here delta H is minus 297 kilojoule per mole. Kilojoule per mole. Okay, this is the 297 kilojoule per mole. This is the energy level diagram for the first reaction. Okay, this is the energy level diagram for the first reaction. You solve second reaction. Draw energy level diagram, label the axes, and show clearly reactant and products and enthalpy change of reaction on your diagram. You solve question number 2 for this reaction. Copper sulfate from copper oxide and sulfur trioxide. Here reactant is copper sulfate, and submit to my WhatsApp number. Solve now. Okay, already one student, two students have submitted this. How? Yes, you have drawn, but here's a problem here. This is endothermic reaction, so reactant energy is lower than product energy. This is correct, but you didn't write what is written in the x-axis. X-axis you should write progress of reaction, and y-axis, in this y-axis you should write energy. This thing you have mistaken. So you shouldn't got excellent, you should got good. Next is this one. No, this one. He has mistaken. This student mistaken. This is this should be top. At the top should be not. This is endothermic reaction. Here will be reactant will be below. Reactant will be here below, and product will be top. Because this is endothermic reaction. Progress of reaction is written correct, but here you should write energy in the y-axis. You not it is wrong totally. Okay. Thank you for submitting. এখন এটা কে দিল? আর কেউ দিস নাকি? এটা ইরেজ করে দিছে। এটা উল্টা পাঠায় কেন? ছবিটা হ্যাঁ, now is correct. Okay, this is correct now. This is reactant. Reactant তুমি left hand side দেখতা, left hand side reactant আর product. Yes, something missing. Salman Sakib. Okay, now I am drawing. Look. Okay, there is a reactant is copper sulfate, and product is copper oxide and sulfur trioxide. Here this is endothermic reaction. So এটা কে দিল? This one is correct. Progress of reaction, actually products. Okay, look, this one is correct. Energy, progress of reaction, copper sulfate is reactants and products. At first you write reactant, left hand side reactant, right hand side product, always left hand side reactants and then products. Okay, this is actually absolutely correct. This one we have done. Excellent. What's the name this student? Wow, Satman, thank you, Satman. Excellent. 100% correct. He is a top scorer in the first liquid test. এটা রং করছে আগে লাগবে এটা লিখে ফেলছে exothermic. This is wrong. You should at first reactant energy is here less, reactant energy is less. You have written reactant energy is more, below our product will be above. So this is wrong answer. Thank you for submitting. You সাতমান এটা দেখিও কেমন লাগছে। Okay, now I am going to class my so what is this? Okay, now evaluation. Everyone should unmute. Okay, microphone on microphone. Okay, everyone should microphone on. First question is on microphone. What is exothermic reaction? What is exothermic reaction?
Some chemical reactions give out energy in the form of heat. A reaction that gives out heat to the surroundings is said to be exothermic.
Okay, here energy is released to the surrounding. Okay, endothermic reaction. What is endothermic reaction?
A reaction that absorbs heat to the surroundings is said to be endothermic.
Yes, again.
A reaction that absorbs heat from the surroundings
Yes.
is said to be endothermic.
As a result, reaction area become cool. Okay, give example of exothermic and endothermic reaction. Give examples of exothermic and endothermic reactions. Give examples of exothermic and endothermic reactions. Exothermic reactions, all combustion reaction is exothermic reaction. All combustion reaction, like methane, combustion reaction with oxygen, like methane plus oxygen form carbon dioxide, water. This is the combustion reaction. All combustion reaction is exothermic reaction. All neutralization reaction is combustion reaction. So you can give here endothermic reaction. All decomposition reaction is endothermic reaction. Give example one endothermic reaction. Photosynthesis. Huh? Melting of ice. Yes, melting of ice. Photosynthesis also endothermic reaction. Thank you. And next question is, why energy is released in exothermic reaction? Why energy is released in exothermic reaction?
The products of the reaction
Yes, reactant energy is more than product energy. When reactant to product form, the excess energy is released from the surrounding. For this reason, energy is released in exothermic reaction. Okay, thank you joining for joining the class. I will submit assignment 5 minutes because I didn't prepare. Okay, wait, everything I give. Thank you for joining.